Imagine you would like to investigate the relationship between countries' resource endowment and corruption, often identified as one of the issues in the studies of resource curves. You can start with a simple hypothesis. As the country's percent of resources increases, the corruption level increases. At a very basic level, you can express this simple hypothesis with a simple additive equation in the form of something like this. Corruption equals B0 plus B1 times resources. You realize, however, that the degree to which resources affect countries' level of corruption depends on the institutional structure of the country. Again, in simplistic terms, you posit that it is plausible that countries with autocratic leaders are more likely to pocket the natural resource revenue as there are lower or non-existing accountability checks on them. Democratic leaders, on the other hand, are held more directly accountable by the populace in regular elections, and so pocketing natural resource revenue may simply be much more difficult. We can translate this line of thinking into a hypothesis. For example, as countries' natural resource endowment increases, autocratic countries will have higher level of corruption than democracies. We call this hypothesis a conditional hypothesis because the effect of resources on the corruption is further conditional on the regime type of the country. In our case, whether it is a democracy or autocracy. How do we then go about translating this idea and the hypothesis into a statistical model? We use a so-called interaction effect to capture the conditionality of the proposition. The model then can be rewritten in the following form. Again, corruption equals B0 plus B1 times resources plus B2 times regime, and then we add another term, the interaction term, in the following form. B3 times regime times resources. What does this model look like when we estimate it in R? We must first select the measurement of our variables. We chose corruption as a continuous index from 0 to 20. So the higher the number, the higher the corruption in a country. We also included regime, which is a dummy or dichotomous variable coded 0 if a country is an autocracy and 1 if a country is a democracy. And lastly, we included resources in terms of percentages of GDP. We obtained the following output from R. Those of us who have already worked with R, the format of the output looks just like any other OLS or linear regression output we have worked with before. However, because of the inclusion of the interaction effect, the interpretation of the coefficient or coefficients is now different. And that's what we turn our attention to for the rest of the class. The value of the intercept is the same. It is the estimated level of corruption for autocratic countries. The interpretation of the second estimated parameter is now the estimated effect of resources for autocratic countries on corruption. In this case, when variable regime is held at 0. For 1% increase in resources as a percentage of GDP for autocratic countries, the estimated average corruption increases by approximately 0.017 index points. So this is a very small effect indeed, considering that the theoretical values for the index range from 0 to 20. The coefficient for our third term is now interpreted as we move from autocracy to democracy for countries with 0% resources as a percentage of GDP, the estimated average corruption decreases by 5.8 index points. Now, this is arguably a much larger effect, but the problem here is that it is not entirely informative as a case of interest. What are precisely countries with 0% resources? Very few countries are very close to 0. Thus, we may be more curious about countries that possess some natural resources at least. For that, we turn to our last term in our equation. Now, in this case, we need to do a bit of algebra to understand the substantive interpretation of the interaction effect. Why is that? Well, because the slope coefficient is here given for the multiplication term, and thus the slope may be different given which value we hold our regime variable at. So let's get started. Let's start with the intercept and the slope for the autocratic countries. We start with the basic equation and substitute 0. Two terms fall out of the equation, and then we proceed to rearranging the like terms together. We now obtain the differential intercept and the differential slope for autocratic countries. The last step is to substitute back from the regression output. Now we can go through the same process to obtain the differential slopes and intercepts for democratic countries. We start with the basic equation, but now we substitute 1 instead. Then in the same way, we can rearrange the like terms together. Again, we substitute back from the original R output and add them where appropriate. Now we have obtained the differential intercept and differential slope for democratic countries. We can also plot these intercepts and slopes that we just calculated for each of the regime type. So what can we conclude substantively about this outcome? Let's go back to our hypothesis. As countries' natural resource endowment increases, autocratic countries will have higher level of corruption than democracies. Is this hypothesis supported by our data? Well, not entirely. While autocracies have on average no doubt higher level of corruption than democracies, just compare the two intercepts. For autocracy, it is 10.54 on our index scale, and for democracies is 4.6 on our corruption index scale. The effects of the natural resources in both autocracies and in democracies are rather small. They're quite close to 0. So the results are a mixed bag, and that is okay. The idea here is not to affirm a hypothesis. We can carefully speculate about reasons why we find small effects like this, and why we don't see much evidence for the hypothesis in our sample. For example, one of the reasons could be sampling issues. The sample of countries may have oversampled countries with relatively small resource endowment, where we are simply unlikely to observe the most dramatic manifestation of the resource curse.